Hi, welcome to this third introductory video where we will see the first two of the three types of geometry. If we draw a timeline of the evolution of geometry, then geometry was used in different disputed forms in various places since ancient times. And the first significant development happened in the 2nd century BC when Euclid of Alexandria collected all the scattered geometry, organized it, proved the characteristics of shapes, and published the whole as a body to the world in his book Elements, a little of which we saw in the previous video. Thereafter, because of Euclid's book, the use of geometry expanded, but there were no new developments in it until the 17th century AD when René Descartes invented a system whereby an algebraic equation could be expressed as a geometric shape and vice versa. In this system, graph paper is divided into four parts. The point of intersection of the dividing lines is of value 0. For the horizontal line, the right hand side has positive values, and so on by taking broader paper, and the left hand side has negative values, and also so on by taking broader paper. The horizontal line is called the x-axis and is labeled x on the positive right side and x dash on the negative left side. For the vertical line, the upper side has positive values, and so on by taking longer paper, and the downside has negative values, and also so on by taking longer paper. The vertical line is called the y-axis and is labeled y on the positive upside and y dash on the negative downside. Graph paper, after the division into four parts, marking of values and labeling of x and y axis, is called a Cartesian plane, and this whole system of algebra cum geometry is named Cartesian geometry, both in honor of René Descartes. Now to see how algebra is expressed as a geometric shape, we will take an algebraic equation, say y is equal to x. This equation is saying that the value of y will be whatever the value of x. So we make a table in which we let x take any different values. Now since as per the equation y is always equal to x, then when x is 0, y will also be 0. When x is 1, y will also be 1, and if x is 2, y is 2. Next we consider the first set of x and y values in our table. If x is 0, y is 0. Now if you see the Cartesian plane, x is 0 and y is also 0 at this point. The second set in the table, when x is 1, y is 1. Now in the Cartesian plane, x is equal to positive 1 along this line, and y is equal to positive 1 at this level, and the point where the two lines coordinate is where x is 1 and y is 1. The third set in the table, when x is 2, y is 2. Now in the Cartesian plane, x is equal to positive 2 along this line, and y is equal to positive 2 at this level, and the point where the two lines coordinate is where x is 2 and y is also 2. Notice that at each of these points, the respective x and y values are together in coordination. Hence, each point is called a coordinate, and the Cartesian plane is also called the coordinate plane, and this geometry is also called coordinate geometry. Now lastly, we join the dots and we have the algebraic equation y is equal to x expressed as a geometric shape, a straight line. And in this way, depending on the algebraic equation taken, we can get other geometric shapes like a curve, a parabola, a wave, etc. A geometric shape obtained can then be analyzed visually to understand pictorially the meaning of the algebraic equation from which the shape was obtained. For example, for the straight line obtained above from y is equal to x, if x represents number of chocolates bought and if y represents the resultant amount paid, then an elementary pictorial analysis is that since the line rises upward and to the right, y is equal to x means that as the number of chocolates bought increases, the amount paid also increases. Hence, this geometry is also called analytical geometry. We will be studying this geometry completely in a separate series of videos. The explanation here was just to inform you of the second type of geometry. This geometry led to exciting advances in other branches of mathematics like trigonometry and calculus. Okay, now to summarize and remember what we learnt in this video. The purpose of this video was to see the first two of the three types of geometry. We first recollected that in ancient times too, geometry was used in different disputed forms until in the 2nd century BC, Euclid of Alexandria collected, organized, proved and published the whole of geometry in his book Elements. Thereafter, while the use of geometry expanded, the next big development in geometry was in the 17th century AD when René Descartes combined geometry and algebra. We saw the system on graph paper and how an algebraic equation could be expressed as a geometric shape, a straight line. We also saw that different equations can result in different geometric shapes. We further saw that any geometric shape thus obtained can be analyzed. This geometry began being called Cartesian geometry, and the graph paper divided into 4 parts and values marked the Cartesian plane, both in honor of its inventor René Descartes. This geometry is also called coordinate geometry because the points marked on the plane are coordinates of two values from the two sides of the algebraic equation taken, and hence the Cartesian plane is also called the coordinate plane. Further, since the geometric shapes obtained can be analyzed, this geometry is also called analytical geometry. Lastly, we saw that this geometry led to advances in other branches of mathematics like trigonometry and calculus. Alright, in this video we saw the first two of the three types of geometry. We will carry this forward to the next video where we will see the third type of geometry in this space here. We will also see that of the three types of geometry, why we must start with Euclid's geometry in this space here. I'll see you in the next video.